Welcome to this SQL tutorial on stored procedures and functions. In this lesson, we will explore how to create reusable logic inside a database using MySQL Stored Procedures and SQL functions. In many real-world database systems, developers often need to run the same queries repeatedly, which can lead to inefficiencies and errors. To solve this problem, relational databases allow us to store SQL logic directly inside the database. This logic can then be executed whenever needed using stored procedures and SQL functions. To begin our demonstration, we will create a simple employee table. This table will store basic employee information, including an ID and a name. First, we remove the table if it already exists to ensure our script runs without errors. Then we create the employees table with two fields, the employee ID, which serves as the primary key, and the employee's name. After creating the table, we insert a few sample records representing employees named Safak, Mike, and Carol. Once the data is inserted, we run a select statement to confirm that the table contains the expected records. Now that our table is ready, we can begin exploring stored procedures. A stored procedure is a block of SQL statements stored inside the database that can be executed on demand. Stored procedures are useful for automating repetitive database tasks and enforcing business logic within the database system. Our first stored procedure will not require any parameters. Inside this procedure, we update the employee whose ID is 1 and change their name to Steve. After defining the procedure, we execute it using the call statement. When we run a select query again, we can see that the name for employee ID 1 has been updated. Next, we create a more advanced stored procedure that uses parameters. SQL procedures can accept 3 types of parameters: in for input, out for returning a value, and inout, which both receives and returns a value. In this procedure, we pass an employee ID as an input parameter. The procedure retrieves the employee's existing name, stores it in an output variable, and then updates the employee's name using the value provided in the inout parameter. When we call this procedure, we provide variables that store the output values. After execution, we display the return values to see both the previous employee name and the updated name. Now let's move on to SQL functions. A SQL function is similar to a stored procedure, but it always returns a value and can be used directly inside SQL queries. Functions are typically used for calculations, transformations, or retrieving single values. This concludes our tutorial on SQL stored procedures and functions. We covered how to create reusable logic, manage parameters, and understand the core differences between these two powerful tools. We'll explore how stored procedures automate repetitive operations and how functions perform reusable calculations, returning values directly within your SQL queries. Let's start by creating a simple function that doesn't require any parameters. Our first function will count the number of employees in a table, demonstrating a basic reusable calculation. Inside the function, we declare a variable, use a select count statement to count the rows in the employees table, and then return that result. Now let's execute this function to see the result. When we run a simple select statement that calls this function, the database executes the stored code. The database returns the total number of employees currently stored in the table as the output of the function. Next, we'll create a function that accepts input parameters to perform more dynamic operations. This new function receives an employee ID and a new name, allowing us to update specific records. The function first retrieves and stores the employee's current name in a variable called oldName, and then updates the employee record with the new name provided. Finally, the function returns the previous name, so we can verify which value was successfully replaced during the update. Understanding how to manage and clean up stored programs is crucial for database maintenance. You can view the stored functions and procedures defined in your database using the Show Function Status and Show Procedure Status commands. To clean up, we drop the stored functions and procedures using the drop function and drop procedure statements. Let's quickly summarize what we've learned in this tutorial about SQL stored programs. Stored procedures automate complex operations, while functions perform reusable calculations and return values directly within SQL queries. Understanding these features is an essential skill for database administrators, data engineers, and back-end developers, improving efficiency and security. In the next tutorial, we will explore more advanced SQL features such as triggers, views, and database optimization techniques. Thank you for watching, and keep practicing your SQL skills. Welcome to this SQL tutorial on database views. In this lesson, we will learn what views are, why they are useful, and how to create and modify them in a relational database system such as MySQL. In many real-world databases, information is stored across multiple tables. While this structure improves organization, retrieving useful information often requires complex queries that join several tables together. To simplify this process, SQL provides a feature known as a view. A view is essentially a virtual table created from the result of a SQL query. Views do not store data themselves, but present data from underlying tables in a simplified format. They are commonly used to simplify complex queries, improve security, and create reusable data structures for reporting and analysis. Let's begin by creating our sample dataset. We will set up two tables, employees and departments. First, we drop and then create a new queries table. This table includes employee ID, name, salary, and department ID, with employee ID as the primary key. We then insert several employee records, noting one employee without a department ID for later demonstration. Next, we create the departments table with department ID and department name columns. We then insert several department records, representing different divisions within the organization. Now that both tables contain data, we can retrieve combined information using a join query. This is where the complexity begins. This query selects employee ID, name, salary, and department name by joining the employees and departments tables on the department ID. We use a left join to ensure all employees are included, even those without an associated department. While this query works well, imagine needing to run it repeatedly for reporting or analytics. Writing the same join query every time can be inefficient and time-consuming. This is precisely why views are so useful. Let's explore how to create a view and retrieve data from it easily. We create a view called employee_department_view. The view stores the entire join query. From the user's perspective, this view behaves like a regular table, acting as a stored query. Once the view is created, we can retrieve data with a simple select statement. Instead of rewriting the entire complex join query, we simply select all records from the view. Next, let's look at how we can modify the underlying data through the view itself. We attempt to update an employee's salary directly through the view. However, this attempt results in an error because views created using certain joins may not be directly updatable, depending on the database system. To successfully update the data, we recreate the view using an alternative syntax, joining the tables using a where condition instead of the left join. With this replacement, the update operation succeeds, and the employee's salary is modified. When we query the view again, we can confirm that the change has been applied successfully to the underlying table data. Finally, when the view is no longer needed, we remove it using the drop view statement. Let's summarize what we've learned. A view is a virtual table based on a SQL query. Views simplify complex joins, improve database security, and make queries easier to reuse, making them essential for reporting systems and data analytics. Thank you for watching, and continue practicing your SQL skills.